Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for over a decade, and I've achieved a 99th percentile GMAT score and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS believe that our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 39. Doing real GMAT problems is one of the most proven ways to make test day go well, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be extremely similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to take away from each question. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You may not be able to execute every step in your head if you're on the go, but just do your best. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. We've done a lot of problems together in this series so far, and it's a good time to start tackling some more challenging questions. I'm still going to start with a slightly lower difficulty level warm-up problem, but we're going to bump up the difficulty level quite a bit more than past episodes from there. So if you find these a little too challenging, I'd recommend going back to some of the earlier episodes and just work your way up to where you're comfortable engaging with this material. This is problem number 1. The question says, if x is greater than 0, x divided by 50 plus x divided by 25 is what percent of x? I'll read that again. If x is greater than 0, x over 50 plus x over 25 is what percent of x? Option A is 6%. Option B is 25%. Option C is 37.5%. Option D is 60%. And option E is 75%. Again, recommend pausing and getting as far as you can. I'm just going to jump into my commentary. Really good warm-up problem. Quite a few different solution paths that work here. So I'm going to discuss one specific path that I think you're going to find particularly useful, but I do want to say up front that if you solve this one a different way, that's completely fine. And as long as that's working for you across a wide variety of questions, there's no need to change. But if you're not having success with your current approach to this type of question, then I think our conversation right now is going to be quite helpful. The fact that there are so many approaches makes it a good entry point for the topic of percents, because I think there are a lot of intuitive ways to solve percents questions that can work really well on certain types of problems, but that don't always apply broadly. And I've seen a lot of people get in trouble with that. So again, if the way you're doing it now is all good, great, keep doing what you're doing. But if you're finding that you're having success on some percent problems, but not others, this should be a very valuable conversation that'll help you eliminate mistakes and also have less information that you need to memorize, rather than memorizing like 30 different techniques for 30 different types of percents questions. So if that simplicity sounds good, that's what we're going to talk through. So we've gone through this approach in previous episodes in this series, actually. So apologies if it's a bit repetitive, but I'll run through it quickly. And if you're new here, that should be helpful. And if you have been around for a while, then hopefully it's a good refresher. So in any percent word problem on the GMAT, certain words are always going to represent the same operations. For example, the word of always means multiply. The words is, are, were, and was are always going to mean equals. The word percent always means divide by 100. And the word what always means make a new variable, a variable that hasn't appeared in the problem already. So I want to reiterate, that's for percent word problems on the GMAT. That's not in 100% of cases in life, and it's not even every word problem on the GMAT itself. It's percent word problems, okay? So make sure that you're applying it in that situation. It can sometimes apply more broadly, but it does not always apply. So when I'm saying the word always, I'm talking about the limited scope of percent word problems. But there are quite a few percent word problems on virtually everybody's GMAT these days. So it's a good one to have in your toolkit. I like this approach for a lot of reasons, actually, but simplicity is a big one. Anytime we can keep our approach simple, even complex questions tend to get easier, and we'll explore that idea more when we get into some of the harder questions. For now, let's take a look at how this system could help us on the current question. First of all, we've got x over 50 plus x over 25. So let's just write that as is. And then we get the word is right after that in the question text. So to the right of x over 50 plus x over 25, I would write equals, because is always means equals in percent word problems. After that, we have the word what. So I'll make a new variable. In this case, I'll choose the letter P as in purple, but you could use any letter that doesn't appear in the problem already. That's the new variable piece. That's actually an important point to emphasize. I don't want to make that new variable x, because x is already defined to be a different number in the question, and that's going to create a ton of problems. So remember, what means a new variable, a variable that has not appeared in the question already. So that's partly why I'm choosing p. Then we get the word percent. So I'll divide p by 100. So I'm just taking that translation system and I'm just applying it one word at a time. So far, I have x over 50 plus x over 25 equals p over 100. Then we get the word of. That always means multiply. And then, of course, x just means x. So the entire phrase in the original problem, x over 50 plus x over 25 is what percent of x. We can translate that one piece at a time to be x over 50 plus x over 25 equals p over 100 times x. Again, probably not the fastest or maybe even the coolest way to do the question. Doesn't get a lot of clicks on the forums, but it's simple, it's relatively easy to memorize, it's very repeatable, and it applies in a wide variety of situations. So again, if you struggle with translations or the setup on these kinds of questions, I think you're going to like this a lot. Once we've got that equation, we can use some algebra to solve. Quick aside, if you're just starting your journey or you feel like you could use a refresher on some basic math concepts, then we've got an entire GMAT Math Basics series linked in the description that I think you're going to find super, super helpful. It's basically what I needed when I was in your shoes starting out, and it had been a couple decades basically since I had done a lot of this stuff. So definitely feel free to work through that and return here when you're ready. There are a lot of ways to execute the algebra. So I'm just going to give one example of what could work, but there's no need to stick to these steps if you have a way that's already working well for you. So let's start by consolidating the fractions x over 50 plus x over 25. I'll create a common denominator of 50 by multiplying x over 25 by 2 over 2. That gets me x over 50 plus 2x over 50 equals 3x over 50. Now I've got 3x over 50 equals p over 100 times x. Many options here. I'd probably just multiply both sides by 100, though, to get rid of the fractions. That would get me 100 over 1 times 3x over 50 on the left, and just p over x, just p times x on the right of the equal sign. I can cancel the 100 over 1 with the 50 in the denominator of 3x over 50 to get 2 over 1 times 3x over 1. And that gets me 6 times x on the left. On the right, I still have p times x, so I'll divide both sides by x to get 6 equals p. And that gets me my correct answer of 6%, which is option A, as in alpha. One final time, that's not the only way to do the problem, but it's a really good problem to introduce the technique. And if you have another approach that you like a lot better that works in a wide variety of situations, that's great. That's great. There's no need to change. In terms of wrong answers here, most have just 1 or 2% of us picking them. So my guess is those just represent some math errors or some reading or setup errors, but it doesn't seem super pervasive. And we've probably talked too much about preventing those kinds of mistakes in past episodes of the series. So I'm going to gloss over those for now. And I'm going to wrap up our warm up problem and we'll jump into some questions you may find a little bit more challenging. If there's anything you want to remember from that question, now's a great time to pause and make a note to self, maybe emailing or texting yourself if you're on the go, and then we'll move forward. Please pause if you want to make that note. And I'm going to jump right into our second question. So going up the difficulty spectrum here, okay? The question says, if m is greater than 0 and x is m% of y, then in terms of m, y is what percent of x? I'll read that again. If m, the letter m used as a variable, as in midnight or Monday, if m is greater than 0 and x is m% of y, then in terms of m, y is what percent of x? Option A is 100 times m. Option B is 1 divided by 100 times m. Option C is 1 divided by m. Option D is 10 divided by m. And option E is 10,000 divided by m. Again, recommend pausing, get as far as you can on your own. Okay, by the numbers, this one appears to be quite a bit harder than the previous question for us as a group. 10% of us missed the first one, 31% of us missed this one. So seems like it's more than 3 times as hard to get this question right, even though on the surface it may not appear all that much more complicated. So let's dig into why that might be and give you some tools for making this type of thing easier. First, why are so many of us missing this? It's really easy to get confused by the phrase m% in the problem. This is something I see come up a lot for folks. For example, some of you might have thought about plugging in a number here, which is great. That is a really, really great approach since you have variables in the answer choices. But what often happens is folks are going to plug in something like 20%. Conceptually, they're thinking, okay, I want this to be 20%, but instead of making m equal to 20, they end up making m equal to 0.2 or 20 over 100 or something like that. But if you think about it, if you read that through in the problem and you replace the letter m with 0.2, now you're saying 0.2%. So that word percent right after the variable, it might not seem like that big of a deal, but it's a huge, huge deal. It's probably the difference between being right and wrong for like a healthy percentage of us here. So again, super common mistake. If you're going to make that mistake, make it in practice. If you're going to make mistakes in general, make them in practice. Mistakes aren't always a bad thing as long as you learn from them and you can improve and you can get value from them when it, quote unquote, really counts on test day. Of course, what we want to avoid is repeating mistakes. So if that happened for you in this question, you're definitely not alone. And I made that mistake many times when I was studying. And I'll give you some tools for that in a moment. But that might end up being a good note to self on this question for you. What's interesting is that same mistake usually also affects people's algebraic approach to the question. So it's independent of the type of strategy you pick. It's just a very pervasive difficulty. For example, many people translate x is m% of y as x equals m times y. Again, very, very understandable, but the problem is it's not right. So if you do that, or you make the previous mistake, it's highly likely you're going to end up with option C as in Charlie. And it looks like about 15% of us end up going down some version of that path. So that's a lot. Imagine 100 of the brightest future business leaders in your generation in a room, 15 of them are going for that. That seems like something that we should join hands together and fix. So how can we prevent that kind of thing? These kinds of situations are a huge reason that I recommend the approach in the previous problem. If you translate questions like this one step at a time using that framework of means multiply, what means a new variable, percent means divide by 100, and is, are, were, was means equals. If you use that framework consistently, it's a lot less likely that you're going to mix anything up during the translation phase, and you'll probably get this question correct much more often. So let's walk through how that might look. I'm going to go through the problem text one piece at a time. X means X, I just write X. Is means equals, I write equals right to the right of X. M means M, I write an M. Percent means divide by 100, so I would just put a slash 100, or I would make a fraction bar and divide M by 100. Of means multiply, so I'd write a little dot for multiply. And then Y means Y. And if we go through that process, we should end up with X equals M over 100 times Y. And you'll notice that would solve the whole M equals 0.2 versus M equals 20 thing. A small adjustment, simply writing M over 100 instead of M, but that increases your likelihood of being right here by about 15%. So I think it's worth it. When a problem says M%, that means you want to represent M equals 20 if you're going to plug in a number. If you want to use 30%, you want to make M equal to 30 if you're going to plug in a number, okay, not 0.3. So that'll help you if you're plugging in a number. If you're going to use algebra, then I recommend the technique we just talked through. And again, I like it for the simplicity. Like, I don't have to think too much about what I'm doing with M there. It just kind of happens the right way automatically. And that's the kind of system that I like to lean on when I'm under time pressure and the stakes are high. Something that's hard to mess up. Note that we can also apply the same technique to the actual question that's being asked, which is Y is what percent of X? That just becomes Y equals P over 100 times X, P being the new variable I'm creating. And if we have Y equals P over 100 times X, and we have X equals M over 100 times Y, if we translate like that, and we want to solve for P, we can just use some substitution, and things should work out well. Again, the number testing thing also works, but I'm going to use the algebra thing just, first of all, to mix it up, because we've been talking about plugging in numbers a lot recently. And both techniques are worth understanding, at least, even if you default to one or the other. And also, I just want to emphasize the value of that approach I was talking about in the previous question. So I'm going to talk through the algebra again. Want to emphasize plenty of alternatives for using and executing algebra. This is just one potential path. But if I replace X with M over 100 times Y, because X is equal to M over 100 times Y, if I substitute that into the equation Y equals P over 100 times X, then I would get Y equals P over 100 times M over 100 times Y. And I want that equation because I want to solve for P in terms of M. And we've talked about that phrase in terms of in the past. If you're just starting out, it can be confusing, but that just means only M on one side of the equation when I solve. So when I solve for P, I want only the variable M on the other side of the equation. That's what in terms of M means. And you can see that reflected in the answer choices, which don't have any Y's or X's in them. So again, check out that Math Basics series if you want a refresher on substitution and how that works. Might have been a while since you substituted for a variable in an algebraic expression. The reason substitution is so valuable is you can make variables disappear. With that substitution, we made X completely disappear from the problem, which is nice. I don't want X to be in the problem. I just want P and M. Speaking of making things disappear, once I have that equation, Y equals P over 100 times M over 100 times Y, I'd probably just divide both sides by Y to get rid of that variable. And that would leave me with 1 equals P over 100 times M over 100. From there, I would use a similar principle to what I used in the previous question to get rid of the fractions as soon as possible. To do that, I would just multiply both sides of the equation by 100 2 times to get the two hundreds in the denominators to cancel out. So that would give me 100 times 100 on the left, because that's on the left I just had 1 before. And 100 times 100 on the left would equal P times M. So I've just got rid of the denominators on the right. We want to solve for P. That represents the what that the question's asking for. So we'll divide both sides by M to get 10,000 over M equals P. And that leads us to our correct answer, which is option E, as in echo. Like I said earlier, not the only way to do the problem. And if you're having success with your current approach, it's usually best to stick with what works until it stops working broadly or stops working as consistently as you'd like to. But if you were totally stuck on this one, or you ended up falling into one of the many traps, I only talked about one of the traps, but there's a couple others here, then I'd recommend adopting the translation technique I just walked through. The reason I'm not going through those other traps is they basically just come back to the exact same takeaway uh, of like, use the technique I talked you through. And I didn't want to be too heavy handed with my advice there. I guess I want to be the right amount of heavy handed with my advice. Again, if there is a note to self to make for you, then I recommend pausing and making that now. And then we will wrap up with one more question that's, I think, comparably challenging. This question is actually not from the OG 11th edition. This is from an old retired GMAT practice test series. That's also out of print, so very unlikely it's going to appear anywhere in the future. But it's I checked, and it's, as far as I can tell, not in the new official guide, and I haven't seen any of the questions from those old exams in the official guide yet. So we should be safe here. But if someone at GMAC is not feeling good about this, definitely reach out to us anytime. And yeah, we're happy to not infringe on anyone's rights here. So let's jump in. More of a word problem here. It says Dara ran on a treadmill that had a readout indicating the time remaining in her exercise session. When the readout indicated 24 minutes, 18 seconds, she had completed 10% of her exercise session. The readout indicated which of the following when she had completed 40% of her exercise session. I'll read that again. Dara ran on a treadmill that had a readout indicating the time remaining in her exercise session. When the readout indicated 24 minutes, 18 seconds, she had completed 10% of her exercise session. The readout indicated which of the following when she had completed 40% of her exercise session. Option A, 10 minutes, 48 seconds. Option B, 14 minutes, 52 seconds. Option C, 14 minutes, 58 seconds. Option D, 16 minutes, 6 seconds. Option E, 16 minutes, 12 seconds. Again, recommend pausing as always. Get as far as you can. So, we set up a strong translation algorithm for percents. This problem explores a somewhat different issue. So I wanted to include this here so that you're not thinking that the first technique is like a silver bullet, like it's going to solve every single percents question you ever see. It won't. But for percent translations questions, similar to the previous two, which are highly likely to come up on your official GMAT, that works great. But again, don't want you coming away from the episode being like, oh, cool, if I just memorize this, I'm going to get every percent word problem right. Not quite. Not quite. I want you to know there's other stuff out there. There's not a ton of other stuff, but there's a couple things, and so this will be a good way to discuss one of the other things. It's a great example of a problem that takes a kind of a different path toward being challenging. So by the numbers, it's a similar difficulty level to the previous one. One note is people tend to take a lot longer on this question on average. I think the average time to the correct answer on this one's 2 minutes and 37 seconds, where on the previous one it's 1 minute and 58 seconds. So not a huge surprise that we've got the unit conversion here that we don't have in the previous one. And unit conversions usually are time intensive, especially because we don't have a calculator on the quant section. So we've got to do a lot of that by hand. I'll have some advice for you on that in a minute. But in terms of the right-wrong mix, it's in the same ballpark. So what's happening here is instead of using some tricky wording to test whether we're dividing by 100 or not, this question uses some tricky wording to test whether we're paying attention to things like remaining versus elapsed time. So it's really testing us on our attention to detail. And it can be difficult to have great attention to detail, especially under time pressure. So it's a good challenge. Ultimately, it's going to make you better at virtually everything that you do. But it may be a struggle until you adapt to that and get some technique under your belt and get some experience under your belt. So that's why we're here now. Some simple tools, again, will do the trick for us here. First of all, really easy question to get wrong here. The unit conversion piece of having to deal with minutes and seconds really messes with a lot of people. And that's before we even get caught up with the whole completion percentage versus actual percentage of the sessions she's already, that she has remaining. So it's kind of a couple pitfalls. One of the simplest ways to combat that kind of complexity and that kind of trickery is just to do a good job writing what's given and asked and remain as organized as possible as you solve. And if you've listened to any of the episodes in this Real GMAT problem series, then you've heard me say that a great deal. And that's because, I mean, if I had to pick one or two things, I guess if I had to pick one thing on the quant section that would make the biggest difference for everybody I've ever worked with, it's just writing what's given and asked super consistently. As crazy as that might sound, it's like, really? It's totally fine if you have some disbelief about that. But most of you know how to learn basic material. Like that's what you've been doing your entire academic career, memorizing things, rehearsing things, building skills with basic content areas. Like that's very familiar. The execution piece under time pressure, that's usually less familiar. There's usually way more time pressure and way more trickery on the GMAT than any test most of us have taken up until this point in our lives. That's the situation I was in back when I was in your shoes. And it took me way too long to figure out all these principles. And yeah, I don't want you to have to suffer like I did. So anyway, simple principles, but really powerful. In unit change problems, being organized and writing what's given and asked usually just means being diligent about writing the units as you progress through each step of the problem. The good news here is that if you execute well, there's a high probability of success. The bad news is that if one detail slips through the cracks, then it can lead us down a very wrong path. So let's work on building some good habits together. Again, this is just practice. It's not the real thing. And building habits and practice is generally the key to great execution on test day. If you're practicing great execution before test day, highly likely you'll have great execution on test day. So let's start by writing what's given. We're told the remaining time is displayed, and that's really important. It's probably worth emphasizing somehow when you're writing it down. It's not the elapsed time, it's the remaining time. So we're then told that 24 minutes and 18 seconds is remaining when she's completed 10% of the workout. And that's also really important because that means that 24 minutes and 18 seconds represents 90% of the total workout duration. And it seems like a decent number of us get to that point based on the miss-make ratio. But yeah, it's a very, very easy thing to mix up in percents in general. Unfortunately, for many of us, that's not the only twist in this one. We want the readout when she's completed 40% of the workout. So we just were talking about what's given in the problem. Now we're talking about what's asked. And it looks like a lot of us do the first step right, where we can figure out that 24:18 is 90% of the workout, but then we calculate the total and then we multiply that by 40%. And that would get us to option A as an alpha, which unfortunately is not the right answer. And it looks like about 12% of us are going down that path. So let's work on that. Part of the reason it's so important to write down that the displayed time is the time remaining is that the question asks for the displayed time when she's completed 40% of the workout. It does not ask for the elapsed time when she's completed 40% of the workout. So what percent of the workout is remaining when she's completed 40% of it? Of course, 60%. And if you take 90% of the total and set that equal to 24:18, and I'm going to gloss over some of the unit conversion and computation for a moment, just stay at the high level. If we solve for the total time of the workout by doing that, then we need to calculate 60% of that total, not 40%. And that would get us to the right answer here, which is E, as in echo, 16 minutes, 12 seconds. Now, if you're on the go, it's probably going to be a little tough to fit all that computation into your head, but there are some tricks and shortcuts you can use. And if you're feeling good with those, that's great. It's not critical to grind it out on the numbers on this one, but based on the incorrect distribution percentages, it looks like the setup and the problem comprehension is the issue for most of us. So I want to remain focused on that, not the kind of like details of how to do the math. I'll have a little bit to say about that in a moment, but I'm not going to go through all the unit conversions live. More on that in a second. So if you struggle with the computation, meaning the unit conversions are tough, then the best simple advice I can give you is just write your units down with each step of computation. I said that already, but it bears repeating. You don't have to love it, meaning it's fine to resist doing it. Like, oh man, this is such a waste of time. This isn't getting me any value. I need to be faster. The clock's ticking down. I got to get this thing done. You know, that's a really, really common mindset. And you're coming from a good place with that mindset. Obviously, you want to perform as well as you can, as quickly as you can. But usually when people start prioritizing speed, they're not prioritizing performing well anymore. And there's a tension there. In fact, we've got a whole episode on how to balance speed and attention to detail. It's called How to Get Faster at GMAT Focus Questions. We'll link that below. Let me just make a note here for you. If you want to click through to that, it'll be in the description. Now, again, okay to resist writing the units down, but if you practice writing the units down, then you will start to get faster at doing things well. If you never take that slow down part to really build the habit of writing units, then you'll get fast, but there'll be a ton of risk in your process. Most of us don't want that. It usually ends up being a really long road to the finish line where you kind of under optimize on your first rep, don't see the score that you want to see, and then have to go back to square one and rebuild. It's quite painful. It happens all the time. Look, I'm not going to tell you how to live your life. I'm just here to give you advice that I wish someone gave to me when I was in your shoes. And if you want to make that bet of like, hey, let me just kind of try to get through this and see what the test score is like, there's a small percentage of people who wind up having success with that every year. But it's a very small percentage, just FYI, like 0.00001%. So if you're not in that group, try not to feel bad about that. I'm not in that group. And perhaps obviously like things have worked out well, and things are going to work out great for you too. You just want to follow the right path for you, if that makes sense. Because again, even just one mistake with one word here, remaining time versus elapsed time, can cause even the most capable of us to miss a question that we probably knew the math on. And that can be really frustrating and is the opposite of getting a peak score. If your score doesn't even represent your skills that you actually have, by definition, it's not the best score you can get. So quick demonstration of how I might write the units. For the first computation, I'd write something like 90 over 100 times t for the total time of the workout. And that would equal 24 minutes and 18 seconds. So 90 over 100 times t equals 24 minutes, 18 seconds. And then I would rewrite that as a mixed number. So I would write the 2418 as 24 plus 18 over 60. And then I would write to the right of that minutes. 24 plus 18 over 60 minutes is the same as 24 minutes, 18 seconds. And then I would convert that into seconds by multiplying by a well-labeled fraction, like 1 minute over 60 seconds. That's called a conversion factor, 1 minute over 60 seconds. It's kind of like a currency conversion factor, if you think about it. So all I'm giving you an example of there is what I would write down. I would literally write down minutes, I would literally write down seconds, and I would literally cross those off as I multiply through the fractions, okay? So I'm going to skip over all the actual math. There aren't too many tricks for avoiding the computation here anyway, so it's worth practicing it on your own. But if you can get to that well-labeled point, then it's highly likely you're going to get the problem correct, because most of you are pretty good at math. It's just the setup and how you're executing on the math under time pressure that can be the problem. So to be clear, what I'm recommending is simply writing the units of the quantities and conversions on unit change problems. If you have a unit change problem, just commit to writing the units for everything as you go. It's a good idea to do it 100% of the time, but having that cue of like, oh, unit change problem, I want to remind myself to write the units. Having that cue can be really helpful for becoming more consistent if you struggle with that consistency. Because a lot of building good habits is just reminding ourselves to do the habit enough. So I'm trying to be helpful there. Again, looks like this problem is less about knowledge, like knowing what to do, which I think is really important on the first two questions. And instead, this question seems a little bit more about the execution side. So to finish out the logic, once I have t equals however many seconds I calculate after converting, I simply multiply that number by 60 over 100. And that would get me the total number of seconds that remain on the clock. And then from there, I can take that number, which I think is 972 seconds, and just use the conversion factor of 972 seconds over 1 times 1 minute over 60 seconds. And that'll help me convert back to minutes. And some long division there can be fine. Some fraction cross cancellation can be fine. We've got a lesson on math basic fractions linked for you below if you want some upskilling on that. And we've also got long division in that series if it's been a minute since you've done some long division. But for now, I've done just an inordinate amount of that kind of fraction math on the pod already, so I'm going to just spare you that. But if you get stuck or you have questions about how to execute the computation, you can reach us anytime over DM at the GMAT strategy on current social channels, or you can email us if you prefer. Our public email address is contact, CONTACT, at thegmatstrategy.com. If there's a note to self for you to make there, I'd recommend pausing and making it now. As always, my greatest hope is that this material is going to make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out the free video we made for you on how you can reach your dream GMAT score much, much faster. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.